is Joe Sacher. I'm going to do a quick introduction to REST APIs in general and in Python. The QR code gets to the GitHub link. That'll also be at the end if you guys are interested to shoot a picture. REST has 6 constraints on it. It's a client-server setup. It's stateless. The actual acronym stands for representational state transfer. And so each interaction is using a state and passing it along. If anybody worked in early web where you had a session variable and you maintain the client state, then when you start replicating the servers, getting the state replicated was just a nightmare. REST has a uniform interface that is resource-based. It doesn't matter if the server uses MongoDB, NoSQL, or Postgres, whatever on the backside, it's going to be a resource when you see it. And then that has a representation that's self-descriptive. You can be JSON, XML, XAML, whatever you want. It's a cacheable, whether that's implicit or explicit. If I have an interface where the data doesn't change for an hour, I don't want you pinging me every minute and using up my bandwidth, so I'm going to tell you. It's a layered system. Most often this is for authentication, which is verifying who you are. Then you may have an authorization. The person you are, do they have access to things? You may have internal caches. You also may go to multiple servers inside, and the client doesn't need to know that. They see the one interface. Now, code on demand is something, when REST came out, that was more Java applets, but I think this is actually one of the more interesting parts of REST that's probably going to come again because we have WebAssembly now where we can execute near-native performance in a virtual machine in the browser. So I think we're going to see that more in REST interfaces in the future. REST can be on any protocol that's out there. It's typically HTTP or HTTPS, which is what we'll be using. And you can think of managing that resource with the CRUD acronym. That stands for create, read, update, and delete. And when you look at your verbs, most people are familiar with the get and the post verbs. For HTTP, get is just any website when you're reading it. Post, you're posting a form back. Put is similar to post, but you're using that to update a resource. And delete, you call it out and you're actually deleting that resource. So you need to post a body back to the server to create something. And same thing with put, you send that back to there. And we'll be using JSON for that. You don't need that for a get or a delete because you're just pointing to a resource. And if we look at the URI we have for a resource, you're typically going to have a server and something that tells you that this is an interface, which is our API. Most people agree that having the actual versioning in the URI is the best way to go. It's very explicit. You can see it in logs. And then meetings is our resource. We're actually going to use an IndyPy meeting as our resource that we'll create and delete on here. I'm not covering is security in this. Typically that's done with a call out to a server and then you send it as part of a header, some kind of token that has a security with it. So like I said, we're using an IndyPy meeting as a resource. I just have a formatted string for our primary key. We have the theme of the meeting and then the various topics. And as you saw before, our URI is meetings. I'm using SQL Alchemy as an ORM, so I can abstract all the SQL with it in just an in-memory SQLite database. And my web engine is Flask, and I'm using Flask Restful because that abstracts away a lot of the implementation for the API. It gives you some syntactic sugar for that. So if we look at our get verb, if we go right to meetings, we're going to return a list of all meetings. That makes sense. You may do pagination on this, where if you tried to get all tweets, you'd be downloading all day. So you can use query string arguments to page that down. If we go to the meetings and primary key, we're going to get the individual meeting directly to it. Post, for my API, I don't think it makes sense to post directly to the item itself, so I'm going to go in error. We're actually going to post to meetings when we push it, and here's one of our JSON packages. That's the same thing package that would be for put. Now, if we put to meetings, that doesn't make sense because you want to actually update an actual resource. So we're going to go directly to the February meeting here to update that. Delete, if you go right to meetings, you're saying delete all meetings. That's scary to me, and I don't think we should expose that in an API unless you had a resource that changes a lot, and that makes sense. But if you specify the exact meeting and it exists, you can delete it. So this will come back up later on. For our DB, all we have is we're importing SQL Alchemy and creating a database. Very simple. We'll set up some properties when we create the app. Can everybody see the code size? Okay. So this is a SQL Alchemy model that's based off of the DB model. If you haven't worked with SQL Alchemy before, you create a table name, and then you create some columns. We've got a primary key that's a 10-character string, a theme that is not nullable, so it's a required field. The other topics are nullable, so they're optional for this. The dunder init is simply setting the values, very simple. I have a class method that's actually querying meeting by date. And so here, if you haven't used an ORM, you can think of the query as a select clause, and then filter would be your where clause for that. And so it automatically does that for you. And I want just the first one because I want either one meeting model or none. And my all meetings is simply query all, so that's just like a select clause with no where at all. I have a little helper function as dictionary, and that's simply to convert this to a dictionary, so when I serialize it out. Then I have two methods for persistence. If you session.add and session commit, you're saving it to the database or creating it. Session delete and commit, you're deleting it out of there. And that will do all the persistence we need on the back end. My actual app here is in Flask, and the API is in Flask Restful. And you can see here there's a resource that we haven't described yet. That's what handles most of the logic code for the API. We're importing the database again. I'm using SQLite in memory, and that's a special indicator to say just spin it up in memory. So when it starts, it's always going to be an empty database for us. Now we're instantiating the API from Flask Restful, and we'll add to that. But before the first request, we need to create all one of our tables. And so that'll happen when the web server starts up. And this is adding a resource, and we'll see this next, the meeting resource. And you'll see we have two URIs for it. We have the root meetings, and then we have meetings where we're actually going to get a string in there. So we get it with two interfaces, both with a string meeting date and without one. So if we go into our resources, I'll scroll down to that first. You'll see that we have an optional meeting date that comes in for our different verb methods. So for the Flask Restful, we're actually inheriting from a resource, and then we also are pulling in reg parse, which gives us a parser. This gives you the ability to have a format, and it can handle all of the responses back saying, hey, you forgot this field, hey, this is in the wrong format. So we have similar to our model where we have a meeting date that's a required string, theme is a string, the different topics are strings, but they're not required. And I have some comments in here for people that are just reading through it. With our get verb, we will either have a meeting date or not, and the Flask Restful resource expects a dictionary back at the minimum, but you can also do a dictionary and a response code. I'm making that explicit. It'll default to 200, which is okay up here if you don't provide it, but I'm providing it for each of those. So if meeting is none, we have a get that has no specificity in it, so we're going to take all the meetings from our model, and we're going to use a list comprehension to make those a dictionary. So we're going to return a list of meetings or an empty list, depending if we have them. So that's a very simple setup, and a 200, actually I'm going to shrink that down so it wraps, and a 200 response code, meaning that was okay. If we actually get a meeting date, we're going to actually query by that date to get our meeting model. If it comes back, we know we have one meeting, we can serialize it out as a dictionary and have a 200 OK code. If we don't get it back, you use the same code you would in a web page that's not found. The resource is not found, it's a 404. That's all you need for the whole GET request for the API. It's very simple. For post, we have the same interface to it. We can get a meeting date or not. Response will be the same. For this one, if my meeting date is not none, meaning if I got anything in there, I want to throw an error because I don't want to support that in the API. You should be going right to the meetings URI. And so this is where the parser comes into play. It's going to automatically take what came in, and if you didn't have required fields, it'll throw errors back at the user. If you do have it, you'll get a nice dictionary with all the values in there. So if we have a meeting by that date, we're going to say, hey, this already exists. We can't have two meetings on the same day because Calvin goes nuts. So if we don't have that, I'm going to use dictionary expansion. I actually named the model and the API the same, so that the star if you're not used to that expands them out to named arguments. So that's going to create my meeting model. I save it to the database, and I give them a created value up here, 201. Now my put, same interface coming in. If the meeting date is none, you have to have a meeting date to update it. So it's the opposite of the post, like we discussed. So I'm going to get me a meeting model based on the meeting date. If it doesn't exist, it's a 404. We can't update a meeting that doesn't exist. We're going to parse in the data just the same way. I have a check here. If the meeting date changed in the body, I'm not going to accept that. I want that to be stuck in there. I don't want you to dictate the date. And then all I have to do, I'm walking through each key in the data, and I'm setting the attribute of the meeting model for that property to this value. It's kind of, I wanted two different ways to go through the data that you may not have seen before. But that's just going through and setting every property in there and then saving it to the database. And we'll return back that it was okay. Delete, if we have no meeting date, we can't delete all of them, so we return an error. If we do have a meeting date, we get the model and return a 404 if we can't find it, and we delete it from the database if we can. So all this is very simple. If you understand this, one thing to do would be to try and implement this in Flask without using RESTful and play with the actual JSON. That's kind of the next level in there, which is good to have. So my API to call this, I'm using requests, and I have my base URL defined here. I created a simple data class, and this was just because you're typically going to serialize in and out on the client side. So I have a method to create one of these from a dictionary and to create it to a dictionary. And that's just kind of like the application level code later on that interacts with the API. So I have simple methods here using requests. If I do a get on the meeting date, I'm going to print out the response text so you can see what that's like, which you wouldn't have in the normal function. If it's a 404, I return none because it didn't exist. Otherwise, I create my meeting object from the response. Very simple. Get meetings creates, with a list comprehension again, a list of meetings that we get. And that's the only one I print headers on, so you guys can see what that looks like coming out. Post, same way. You're posting to URL, and with request, you can include a JSON package for it. And if we get a 400, we throw an error. Otherwise, we assume it's correct. Put, very same way, except we're drilling down into the meeting date here. And then if it's a 404, we didn't have the right meeting, so we'll throw error out there. For delete, we're just calling a delete to that same URL and checking if we have a response code. So I've got this where I can run in debug mode for it, and we can see the web server. Actually, let me drop down. So the web server is actually running up here, running the code, everything but this page that we looked at. And we can step through this in debugging, whoops. Debug on here, and we'll step by step on this. I accidentally typed something, it looks like. That's not good. Line 69. Yep. Oh, I must have tabbed this guy out, it looks like. There we go. Nothing's better than live code. Okay, let's try that again. There we go. Okay, so the first thing it's going to do is do a get all. And that's the only one I had the headers in here. So you can see that the content type coming back was identified as JSON. And you can process that. It's an empty list, created anything. And up top, you'll see the request that actually went to the web server. And we created a meeting for February, and we did a post to it, and all we get back is it was created correctly. But we can query meetings again, and now see that we get a list of one meeting, and we converted that in our internal object to one meeting. And we can get it just as a single meeting as we index into the primary key. Now, I took our initial meetings object and we sent it, stored it on the server, we got it back and created another one, and I tested if those were equal, and we can tell that the data made it round trip and was accurate. So now I'm adding the PBJ topic and putting that in there, Now when I get it, you can see that the REST API in Python was added. And now we're posting a new March meeting. And we get all the meetings. You'll see now that we have 2 of them, both February and March. And then Calvin realized that I was presenting in February, so we said, okay, we need to delete the February meeting. And so when we query those back, we have is March, and we delete out March, and now all we have is nothing again. So you can go through this and just see a simple way to talk with the API in there. And that's all I have. Got it right on 15 minutes. I will throw this up if you have want to look up the code, and I'll take any questions you guys have. Hopefully that wasn't too fast.